Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and Fred and I were talking about the scenario we come across a lot where we need to be able to help our clients but influence them to make a decision or change something about what they do when they're not really naturally keen to do that despite what they say outwardly.
Well, the one that caught my attention is you're talking about a situation, and I'm sure it's not just this one time, because I've seen it a number of times. And it was a factory setting, and you're doing some analysis to help them figure out a maintenance plan or frequency or some aspect like that. And you propose it to them. They go, "Oh, no, you don't understand. They'll never go for that because we're all about uptime." And if the philosophy is, well, we just run it to failure and then deal with it after that, I've run into this where the ops manager is, "Oh no, all your work and analysis is to make sure that when you do repairs, they're quicker. You fix the speed of replacement only. You don't touch the line."
Right.
You don't schedule us to go down, even if it's for an hour, because we could be running, as opposed to looking at it in a bigger picture. So that's kind of the one scenario, but there's many other scenarios where no, you can't switch suppliers with the claim of same form, fit, and function, because the last 15 times you've done this, 14 of them were really bad. So let's take a look at this. "Oh, no, we don't have time for that." Okay. It's like, I've run into those, but it's the same kind of scenario. It's the team you're working with isn't seeing the forest for the trees kind of thing.
Right. And look, the scenario you're describing, in this case, it was simply, let's optimize the servicing interval to try and optimize, let's change the servicing interval to optimize the overall amount of uptime, where in this case, servicing actually took a lot longer than the typical repair. It's quite a different sort of manufacturing process. And so as opposed to most scenarios where repairs are considerably more expensive in terms of time and money, this is not the case, which is quite rare, but it's how it is. And so I go, okay, well, this is going to be the servicing interval you need to adopt in order to maximize uptime. And the response was, "Oh, production will never go for that." You go, okay, well, why not? "Because I want to maximize uptime." You go, okay, so we've hit an impasse.
Yeah.
And I think one of the characteristics I always see in those sorts of scenarios is that the data analysis or the analysis that organisation has been able to achieve in the past hasn't been satisfactory. What I mean by that is they haven't had the ability to, in the past, look at all factors and essentially really relate things like preventive maintenance and corrective maintenance and preventive maintenance downtime and corrective maintenance downtime and the reliability curves and the rate of occurrence of failures and all that sort of stuff, and say, this means that the uptime looks like this. And so they have had to revert to gut feelings and some high-level metrics like you'll see some public figures. Right. So some will suggest, you need to have a ratio of PM to CM of 1 to 6. It's just that's based on not a lot. I'm sure for one organisation that did the analysis, that turned out to be correct, but every organisation is different, as you know. Yeah. And so this organisation was like so many others, where they just never had the ability to be able to relate all these different levers they could pull with the metric they're interested in optimising, which was uptime.
Yep. Yeah. And there's part of it is just this is the way we always do it. And this is, it's just culture. This is what we do.
Right.
And there's parts of that. There's resistance to change, just in general. Despite all the data and all the influence and everything else that you could apply, is like, no, we don't want to change. That's not proven. Well, it'll remain unproven until you try it for your circumstance.
Yeah.
Then there's the and I don't get this all that often, is, well, we don't believe your analysis.
Right.
That doesn't align with my preconceived notion of what it should be, kind of stuff. And so they push back on that. Uh, but the data analysis alone is often not enough. And I think that's the point, right? It's if you're
Right.
working with a team or an organization that is very happy just reacting to field problems or reacting to downing events, and I call it getting really good at being a fire department. Um, they they often miss the opportunity because they just don't have that the experience. Just as you outlined, Chris, is well, if we actually took this in XYZ steps, we would have less of these events to have to go roll the fire trucks out for. And trying to convince them to see that. So, and there's all kinds of techniques that go around doing this kind of thing. But I'm curious, did you have a particular thing that helped them break through this, or they fire the ops manager and find somebody that was more open, or what?
Well, we're still working on it, but because the production team hasn't been approached yet because of the concern about that they
Mm-hmm.
wouldn't take it seriously or would say they wouldn't go for it. And so what I'm in the process of doing right now is translating everything we've done into production time. And what I mean by that essentially is produce a beautiful, pretty chart. Horizontal axis is servicing interval. The vertical axis is production time, and say, here it is.
Yeah.
You
No,
want to
I'm
service
thinking
this often?
this is a management chart. This is going to be red, yellow, green things on it, and
No, no, no,
very
no, no.
pretty.
I hate those. I don't think they're pretty. I think they're
No, I'm
think
just kidding.
triggering.
When you said I have to make a pretty chart,
No,
here's what you're doing now. Here's what,
no.
with the same kind of service that we have to do, but doing it on this interval, here's what you're going to get, or
Right.
very likely to get, you know.
I can say, look, I mean, the good thing is the data goes out to about 20 times what the optimal servicing interval appears to be. So I've got
Mm-hmm.
good coverage of the data. But just essentially put this chart together and say, look, if you're all about uptime, then here's a chart. You can see it's about this figure here, but if you want to still do it over here, this is what it means.
Yep.
Go. And
Yeah.
you can't really do too much more than that.
Well, no, I disagree with that. I think presenting the data cleverly or cleanly or succinctly is not always convincing.
I do take your point. I mean, can't do too much more than that in terms of how you present the data. Then there's sorts of things like appearing credible when you tell the story. All the other things I know you're about to launch. I'm sorry, when I said there's not too much more you can do than that, I just meant in terms of how you present the outcomes of said
Oh
data
yeah, no,
analysis.
but that's, I think, one of the fatal flaws of a lot of good reliability engineers is that, well, we did a brilliant analysis. Doesn't that speak for itself? And it goes, well,
Yeah, I'm with you. Yeah,
right,
I concur.
right. So what other? I mean, I'm going to go into, well, there's, find a champion, find somebody that the ops
Right.
manager trusts, and get them on board and let them present it. Have them do it.
Yeah.
Bring the data across. Suss out what the likely objections are, and maybe there's some intrinsic motivation there. Maybe their bonus is based on running for 23 hours a day, and if you
Yep.
take it down for 2 hours, they lose their bonus, kind of thing. Or it could be that's the way they've always done it, and they're just a curmudgeon, and
Mm-hmm.
come hell or high water, it's not going to change. Well, at which point, why did you even start the process?
Right.
But it's, or you look for a compromise. Let's do a pilot. Let's run it, this way. We'll commit to it for a period of time and try it and really look at the data in your factory and see what happens. And then you hope there's not a hurricane or earthquake or something else that happens that screws it all up. But yeah, but that's my main point, is that creating a change in an organization, changing the culture, especially, or even adopting a different technique, a way of solving problems or improving uptime, for example, is often resisted, I guess is the right word for it.
Yeah, and another example we were also talking about is where I did some data analysis for another client who on the previous project, when I did the review, the data suggested that there were some manufacturing defects in certain components.
Oh, and they were happy with that, if I remember that story
Yeah,
right. They were like, "Oh, that's cool. We
yeah.
got somebody to blame. It's not us." Oh, good.
Well, I mean, they weren't quite that cynical, to be fair.
Yeah.
I know which sort of client you're talking about, but it really focused their ability to then dive into to solve that problem. And so I had a second tranche of data from the same component, which was supposedly the remedied component, and they're expecting it to point to manufacturing defects again. And of course, when I do it, the data analysis is pretty clear. This is not a decreasing hazard rate or wear and anything else that usually points to things like manufacturing defects. Actually had a constant hazard rate, which usually means that it's being subjected to randomly occurring external events that, when that system is exposed to, just fails instantly. I think,
Well, and that's
accidents,
when
human error.
when you were describing it, is you didn't know what the failure mechanism was. Here's
I did
the
not
data
know.
set, and yeah, I wanted to include that one in this one because I mentioned it because the way you phrased it was, and then the color just drained out of their face. It's like,
Yeah, that's right. Well, because then the next part of it was, I did the data analysis, and actually it's a good case study or good example for what you're talking about, because they needed convincing. They said, yeah, but several times. And I said, yeah, but when we look at the failures, when we actually look at the mechanism, it's actually plastic deformation. So that the strut has been pushed to a side. It's been bent. And I said, well, just so you know, I know you're expecting that to be indicative of quality issues, but as a rule, when you have a plastic deformation, as you and I know, it's usually one blunt force trauma event, I think is what you called.
yeah, yeah.
So a single event that essentially the component was getting punched in the face by that randomly occurring external stress. And what that means, if anyone is listening to this sort of stuff for the first time, is there's usually a mismatch between the design load and the expected usage profile. Somehow the customers are using this thing in a way that wasn't anticipated when the designers put it together.
Well, that's what I think is part of it, is the resistance. One of those yeah buts you mentioned was, and this is one that you see all the time, is, well, we're using a standard. It might not be exactly the standard for their new technology, but I've seen it where it was a wrist. I've told you this story before. They had a wrist thing, and they had advertising. You could wear it in the pool or the shower or wherever. And their intent was to make it water resistant. And they went to a Swiss watch standard for water resistance, which meant you dunked it in 3 feet of water. And if you wanted a 1 meter resistance, and you swish it around for a few seconds, and you pull it out, knock off the water. And if it's still working, it passes.
Good to go.
But they didn't include in the standard that moisture and corrosion take about a week to really cause havoc on a low voltage system. And and then they ignored that all of those units failed a week later, and they shipped, and then they all failed after a week of being used, or almost all of them. It was like 50,000 out of 70,000 failed within 2 weeks of their initial sales and launch. And the point is that their resistance was, and it sounded similar to one of the yeah buts from these guys, is, well, we're using a standard. The standard, it must be good. I says, well, let's think about how, let's learn from that, and then use that as the influence point going, yeah, but your customers are probably doing this in a different way, or the failure mechanisms related to that standard are not the same ones that are occurring in your system. And that's one of my bones of contention with standards, is they usually don't list exactly what are they looking for. What are they guarding against? What are they protecting you from? They don't say.
You say that's one of the yeah buts I got, which it was, and I can't go into too many details, but suffice to say, one of the yeah buts was, yeah, but it complies with this standard, which is, on the face of it, reads like a pretty robust standard, or
Oh, and I'm quite sure it has, vibration and shock loads and all these other beautiful charts. And here's how you set up your test regime and blah, blah, blah. And I'm like, okay, so how's that relate to your use conditions?
Right. The issue is that it's probably it could be a fantastic standard, but its usage profile is not the same as yours. And they'd say, well, its usage profile is more robust than ours. And we go, there you go. That's the issue. Your usage profile, and I was able to rattle off 3 or 4 examples where the systems were going to be exposed to stresses that the usage profile implied in this standard would never account for.
Right.
But this could happen, or this could happen, or this could happen. And here are certain things where the actual physical characteristics of your system are outside of what you would expect for the system that this standard's catering towards. And I try to use an analogy where you got to think like you're landing on the moon. You tell everybody else you're a young startup company that are doing things that no one else has done before, and you're actually doing very well because no one else is doing what you were doing. So you have that flow down to your engineering team and say, look, we're doing something that no one else has done before, so we shouldn't be shocked when the pre-existing standards, which are based on what everybody else has been doing, not what you're doing, don't necessarily work.
Yeah. And it's a trap, I find. And there's 2 aspects of it. One of them is they're looking for some industry guidance, something to shortcut their need to, fully qualify and experiment and take a lot of time to understand, is this system going to work? And they're going into a market. They don't have tons of field information about how people use their system because they hadn't sold one yet.
Yep.
There's a dilemma there. But the subtle change when you start saying, well, the standard doesn't apply, you can confront them with all that business, but it's a approach. It's challenging their belief. We counted on that. And now you're saying, well, that was a mistake. Well, it's not a mistake. Lots of people do that. Yet it's stepping back in your process and saying, well, which part of the standard wouldn't necessarily apply? Let's think this through. And then when confronted with hard data that says, that's not as robust as we thought it would be, something's different that we need to take care of. So it's still challenging that belief that the standard was good for them. But the part I get in trouble with is, as a reliability engineer, we fall back on the data, the failure mechanisms, the evidence, the plenty of history of standards just not being all that terribly useful for you. When we're really doing is trying to change their behavior. Let's think about how your system's going to fail and what's the use profiles of that and what do we know and don't know. And let's examine where those risks are, as opposed to just say, oh, I'm going to pull standard XYZ up because that's been around for 10 years. Okay. It's a little more nuanced, I think, than solving an individual problem. I think people will realize that once the data comes up, but there's still resistance to it. But I think the approach to influence their behavior is that because they're going to pull out standards on the next generation, they're going to add electronics and go, oh, we need a standard for that. Let's use the taxi standard for under the hood for cars. That's robust. And it's robust, but it's for cars. And you're making a widget that, sits on a handlebar or whatever. It's not the same. Going over the same roads, but the shock profile is going to be completely different.
Well, another example is if anyone's used a photocopier, which I'm sure most of us have, you look at the glass, and you know where I'm going with this.
Yeah. This is a great story.
The glass is what, 3/4 of an inch thick or thicker. You go, why do they need what seems to be bulletproof glass for photocopiers? And the reason is Christmas parties, because
Christmas.
When they first,
this is an Australian thing, I'm sure.
Oh no, it's not. No, it's not an Australian thing.
Okay.
Not just an Australian thing.
Yeah,
but across the world, of course. What was after the first generation of photocopiers were launched? Apparently, it just released a pandemic of people who wanted to photocopy their backsides. They drop their undergarments, sit on the photocopier, and photocopy what the Lord gave them.
Yeah,
Um,
it's
and
just bizarre.
some might say that office workers tend to lead more sedentary lives, and some might also say that there are some office workers who might be a little bit overweight. And of course, so what happens when they photocopy their backsides? Good portion of people fell through. And so what happens right now is essentially photocopier manufacturers manufacture photocopiers to withstand up to 350 pounds of blunt force trauma when someone is doing this for whatever reason.
Yep.
Because what actually happened in practice is, even though it was clearly being used outside what would be a reasonable use case, big office-based companies would simply claim it as a warranty action, and the manufacturers knew that. Right, but they knew what was happening, but they couldn't prove it. So they just bit the bullet and said, you know what? We have to cater for customers that are going to do this, whether we like it or not. It's not fair, but it's just what we needed to do, because we just cannot argue against it. Yeah. As I understand, once someone fell through the photocopier, they tried not to tell anybody about it. And so it was just warranty.
Oh, it broke. Yeah, it must have been temperature fluctuation. Yeah, that was
That's right.
Yeah, no, and then the other solution, instead of putting a lot of glass on it, I have a little multi-purpose printer that has a copier on it. It just doesn't open enough. You can't use it as a step stool. It's pretty fragile plastic all around it. So it's like, I don't think anybody would. Well, depends on the Christmas party, I guess. But
yeah, true.
But they make it so you just can't open it that far. You can slide a piece of paper in there, or maybe a book, but it's hard to put body parts on it.
Right. But those big pseudo-industrial photocopiers, which have to be able to, open all the way so you can have big encyclopedic-like documents copied.
Yeah.
Well, there's no getting around it.
Well, to be fair to and I talked to part of that design team when I ran into them and they talked about this story. It was, to be fair, they actually thought through, well, how, this is a piece of glass that could break. What's likely to be put on here? And they went to the library and got the biggest Oxford English dictionary they could find and dropped it on it. And they improved the mechanical to hold that load, which is nowhere near what a person would be loading it as. And so, but they were thinking, what would a rational person photocopy? And so they looked for stuff that could be copied, but didn't think, and they were thinking paper, and that limited their view of it. Now, influencing the change with those folks, oftentimes is one of the many, many skill sets that's outside of reliability engineering, is facilitating, brainstorming, thinking outside the box. I think there's even one called 6 Hats I heard about years ago. Thinking about problems. Yeah, thinking about things in different ways. But it's one of those things that we need to think of as a reliability engineer, is that oftentimes the way we frame problems, the way we think about things, the way we make assumptions about what's acceptable or not acceptable, are all just indications that we're dealing with something that has to change or should change. And there's going to be resistance to that from all quarters, usually. Mm-hmm. And so the data itself is a starting point, but it's often not enough to actually make the difference. And so there's a lot more goes into it to make that happen.
And as W. Edwards Deming once said, and I won't get the quote exactly right, change is not necessary, but survival is also not mandatory. So
that's right.
You on the one hand, data analysis, you do it well, it usually doesn't misrepresent what's going on. By definition, if you do it well, it can't.
Right.
If you do it properly, it can't. So if you want to push against the data, push against the real world, again, change is not necessary and survival is not mandatory.
Yeah. Good summary. So hopefully we're just scratching the surface on this, how do you affect change and all that stuff. And we've talked about it in the past, different techniques and processes and stuff, but it sure came up in our discussion today, a couple of things we were talking about. Let's talk about that some more. That's good. So if, you're listening to this and you're facing, we've got compelling evidence, but nobody's listening kind of thing, let us know. We'd help to give you a couple of ideas or pointers given for your circumstance. I'll just send you the emails, Chris, so you can answer them. So I'm sure there'll be a flood coming in here.
All right.
And then
everyone wins.
Everybody wins, right? And we get some more, interesting scenarios that we could talk about on the show, all kinds of stuff. But if you'd like to ask us a question or a comment or provide some feedback, that's all welcome. Head over to accendoreliability.com/go/SOR, and you can find a couple of ways to get in touch with us there. Chris and I, like all the hosts, are available through LinkedIn and through our About pages and a dozen other ways, I'm sure, for each of us. But it's an indication that we really do want to hear from you. We're talking about change and all that stuff. So if you want to send us a note to change the way I wrap up each episode, let me know. I'm open to that because it sounds too rote. I got to do something different, but I'll work on that later.
Maybe you're nailing it. Maybe it's people love it. Who knows?
I don't know. Yeah, we do get comments and responses and questions. So something about it's working. But anyway, thanks so much, Chris. Talk to you soon.
Likewise, Fred. Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.